This is Mr. Renfro, and we're going to do a short instructional video on the coordinate plane. This is an example of the coordinate plane. We'll get more in depth about it here in just a minute. It looks like a bunch of grids, and that's kind of what it is. It's a bunch of grids on a piece of paper, or in this case, a screen. Okay, so let's go to the next screen. All right. So the coordinate plane consists of two axes, okay, two axes, or number lines. The first axis is called the x-axis. Now the x-axis goes side to side, or horizontal, and it runs east and west. And you'll notice it's just like a normal number line. You got the negative integers going this way, with the positive integers going this way. So it's just a normal number line. So that's what the x-axis is. Okay? Now, you also have a y-axis. Okay? You have a y-axis. And a y-axis goes up and down. It's an up and down number line that runs north and south, or vertical. Vertical is another word for up and down. Okay? So you can see here that it runs positive is up and negative is down on the y-axis. Okay, positive is up and negative is down. So this is what they look like together. They form the two number lines form perpendicular lines. Remember, a perpendicular line makes a perfect T. Okay, makes a perfect T. And they intersect at 0, okay? So 0 for the x number line and 0 for the y number line. This is where that is, 0 for both. And that's where they intersect. So you have a number line going east and west, or side to side, and you have a number line that is going up and down, or north and south. Okay, the coordinate plane consists of coordinates. Now, what are coordinates? Coordinates are an exact location. An example of that would be that we use every day in life is longitude and latitude. Longitude and latitude is an exact location on the Earth. Okay, but this is not that. This is on a flat two-dimensional sheet of paper, or screen in this case. Okay. And an ordered pair is what a location, how we're going to list a location. We're going to list it as an ordered pair. Now, pair means two. So, consists of an x coordinate. Remember the x-axis a minute ago, the x number line, and the y coordinate from the y number line. An ordered pair identifies a point on the coordinate plane. Now, this is important to remember. X always comes first. You'll see it first here. And Y comes second. And you'll see it second here. That's going to be important for us to remember. So we always have to do X first and then Y second. Okay? Now, as I just said, X comes first, Y comes second. The point where the two axes intersect is called the origin. Okay, 0, 0. So x is 0 and y is 0. And that is called the origin. And that's where we always start anytime we want to find a coordinate. We will always start at 0, 0. And origin is another word for beginning. So that just kind of makes sense. We're going to start at the beginning each time that we try to find a location on the coordinate plane. Now, the coordinate plane is also broken into 4 sections called quadrants. Okay, and these quadrants go counterclockwise. So I'm going to write regular numbers. These are called Roman numerals. Okay, Roman numerals. But this is the number 1. This is quadrant 1. Okay, and in quadrant 1, x, which is always first, remember, will always be positive. And y, which is second, will always be positive. So in quadrant 1, x will always be a positive number, y will always be a positive number. Quadrant 2, and they go counterclockwise. Remember, counterclockwise goes this way on a clock. Okay, counterclockwise goes this way on a clock. So we have x, this time is negative, and y is positive. And the reason that x is negative is because I go left on the number line and up to get to it. Remember, that's positive for y and negative for x. So if we go left, x is negative, and we go up, y is positive. Okay. Now let's try, and the same thing for this one. In quadrant 1, if we go right, that's positive for x. That's positive is this way on x. Negative is this way on x. Okay? And we went up, so that's positive for y, not negative. Negative goes down. So that's why it's positive, positive. Now, quadrant 3. Quadrant 3, we go left, which is negative for x. And then we go down, which is negative for y. Okay? And then lastly, quadrant 4. Quadrant 4, we go right, which is positive for x. And we go down, which is negative for y. Remember, x is always first and y is always second. So we have 4 quadrants. They go counterclockwise. I always tell students that this is normally where 1 o'clock is on a clock. Okay, so we start with 1 there. And then we go counterclockwise. 2, 3, 4. Okay, so that's the order that they're supposed to be. 1, 2, 3, and 4. Okay, so on this coordinate plane, if I had to say, everybody can see point A here. There's point A. Well, how do I get to point A? Well, remember, where do we always start? We always start at the origin, 0, 0. So we always start where I put that red dot. We always start there. So how do we get to A? Well, first, we either have to go right on X or left on X. And remember, this is the x-axis. So to get to that point, would I go right or would I go left? Well, hopefully everybody in here said we'll go right. Okay? So we're going to go right. Now we got to figure out how many places we go right to get to that point. Okay? So first we start here and we go right. Well, how do we get to A? We got to go right 1, 2, 3, 4, 5. So X is going to be 5. X is going to be 5. Okay? Now, what is Y going to be? Well, Y I either have to go up to get to that point, or I have to go down to get to that point. And from this location where I stop for X, I have to go up. So up is positive. So positive 1, positive 2, positive 3, positive 4, positive 5. So Y is 5. So the location of A is 5, 5, which X is 5 and Y is 5. Okay? Now, let's find the location of point B. Again, where do we always start? We always start at our origin. Okay, so this is point A is located at 5, 5. So that's, where is point B? Well, we need an X coordinate and we need a Y coordinate. So how do we get over to B? Do we go right on X or left on X? Well, I hope that you know we go left on X. And since we're going left, that's going to be negatives for X. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So X is negative 6. And then do we go up to get to B or down to get to B? Well, I hope you said we go up to get to B from negative 6 because we stopped at negative 6. That's where we have to begin to get to B again. or get to the point B. We have to go left, -6, and now we have to go up 1, 2, 3, 4, 5. And that's +5 since I went up. So the location of B is x is -6 and y is +5. Okay, y is +5. All right, where is C located? Well, we needed the x and the y for C. So how do we get to C? Well, first we find the x. Where do we start? We always start at the origin. So I'm at the origin, I got to get to C. So am I going to go left or right? All right, go left on the x-axis. So I'm going to start at the origin, go left on the x-axis, and I'm going to go 1, 2, 3, 4, 5, 6. So I'm at -6 for x. -6 for x. Now what's y? Do I go up, positive, or do I go down, negative, to get to C? Well, I have to go down, negative. Well, from -6, I'm going to go down. 1, 2, 3, 4. So -4. So the location of C is -6, -4. -6, -4. All right, let's find the location of D. Point D. Again, I start at the origin, and do I go right, positive for x, or left, negative for x? I'm going to go right, positive. So 1, 2, 3, 4, 5, 6. Stop at +6 for x. Then do I go up, positive, or down, negative to get to D? Well, I have to go down, negative to get to D. How many down, negative will I go? 1, 2, 3. So -3. So D is located at 6, -3. Now these points are also in quadrants. They're in quadrants. Remember, quadrant 1, there's 4 quadrants, remember. Quadrant 1 is always at 1 o'clock. Quadrant 2, then it goes counterclockwise. Okay, you can also have the Roman numerals for these. So hopefully everybody remembers what the Roman numerals are. Okay, so A is in quadrant 1 because it is a positive and a positive. Every point in quadrant 1 is a positive. Okay. Now, point B is in quadrant 2 because everything in quadrant 2 is a negative for x and a positive for y. Negative for x and positive for y. So point B is in quadrant 2. And where is point C? Point C is in quadrant 3 because x is negative since I went left on the number line, and y is negative since I went down on the number line. So x is negative, y is negative. I'm in quadrant 3. I'm in quadrant 3. That's a negative positive. This one's a negative, x and y. All right, well, what about point D? Well, point D, x is positive because I went to the right. X is positive because I went to the right. And y is negative because I went down. Okay, so all points in quadrant 4 will be positive and negative. Positive for x, negative for y. So let's go over that again. If I'm in quadrant 1, x will always be positive and y will always be positive, just like point A here is positive, positive. Okay? If I'm in quadrant 2, x will always be negative, y will always be positive, just like here. This is the negative, this is the positive. Point B meets that criteria, negative, positive. Quadrant 3, which is C, will always be a negative, negative. X will always be a negative, and y will always be negative if you're in this quadrant. Okay. And the last one here, quadrant 4, will always be a positive for x since you went right, and a negative for y since you went down, which is what we have here for point D. We have a positive 6 and a negative 3. Okay. Now, what if something's on a number line? What if a point is on a number line? I really messed that up. So let's go to a different screen here. I messed that up so good. Okay, let's go to a different screen. All right. So what if a point is on a number line or axis? Okay. Well, let's just go ahead and put our x and our y for our ordered pair. Okay. So what would x be? Did I go right or did I go left? Well, I went left from the origin. 1, 2, 3, 4 to get here. Okay. So I went negative 4. Okay, I went left, that's negative on the x-axis. Okay. Now, did I go up or did I go down to get to this point? I didn't go anywhere. So y is 0. If you don't go up or down for y, it's 0. If you don't go left or right for x, it's 0. Okay, so let's give you an example of that. So here's that point. Let's say that point, we'll call it C. So point C is at negative 4, 0. Well, all right, where is point B here? All right, point B is at, did I go right or did I go left to get to it? No, I stayed here. So x is 0. Did I go up or did I go down to get to B? Well, I went up. I went up positive 4. So the location of B is at 0, 4, which means point C is on the x-axis and point B is on the y-axis. It's not in a quadrant. If it were in a quadrant, it would have to be off the axis. Point C is in quadrant 1. Point B is not. Because you can't tell me if point B is in quadrant 1 or in quadrant 2 because it's on the line. So it's not in a quadrant. If a point is on an axis, like B, then it is not in a quadrant. Okay, another thing that we can tell, and this is a neat little trick I like to tell students. Anytime y is 0, you're on the x-axis. Anytime x is 0, you're on the y-axis. So whichever one is 0, x or y, you're on the opposite axis. So again, if y is 0, you're on the x-axis. If x is 0, you're on the y-axis. So hopefully that's been helpful. Hopefully that's not been too much. Okay? And hope you guys have enjoyed this video. If you have any questions, let me know.